Breaking news from Starbase. SpaceX is about to make history once again with the stunning debut of Starship version 2. As the holiday season unfolds, the teams at Starbase are working around the clock on something extraordinary. The 7th Starship flight is rapidly taking shape, and it's bringing groundbreaking innovations to the launch pad. On a fog-shrouded evening of December 5th, under the cover of darkness, SpaceX quietly moved a giant to its launching grounds. Booster 14, the powerful first stage designated for Flight 7, made its dramatic journey from Mega Bay to the launch complex. Even through the dense coastal mist, its massive silhouette told a story of engineering excellence and unwavering ambition. With January 2025 marked on the calendar for this historic launch, SpaceX isn't wasting a single moment. The testing campaign is already in full swing, and what we're about to witness could redefine our expectations of space travel. From enhanced heat shields to redesigned fins, this isn't just another test flight, it's the dawn of Starship's next evolution. Welcome to Elon Musk 24 Hours, your front row seat to space innovation. Let's dive right in. The journey of Booster 14 to the launch pad marked just the beginning of an intense testing campaign. Within hours of its arrival on December 6th, the massive rocket stood proudly against the Texas sky, defying earlier concerns about pad readiness. SpaceX's engineering team, working with precision that would make a Swiss watchmaker jealous, began preparations for the most critical pre-flight tests. The first major milestone came on December 7th with a spin prime test, a crucial choreography of machinery where a single Raptor engine's turbopumps whirled to life. Picture this: liquid oxygen and methane flowing through the veins of this mechanical beast, simulating the moments before ignition. But here's what makes this test particularly fascinating. It's like practicing a symphony without making a sound, allowing engineers to perfect every movement before the actual performance. But the real showstopper is yet to come. SpaceX has scheduled what could be their most ambitious test yet, a full 33-engine static fire, potentially happening as early as Monday. This isn't just any engine test. It's like conducting an orchestra of rocket engines, all needing to perform in perfect harmony. The test window runs from 8 a.m. to 8 p.m., and for those brief 2 to 3 seconds when all engines ignite, Starbase will witness power equivalent to several commercial airliners taking off simultaneously. Speaking of power, let's talk about what makes Starship V2 truly special. Ship 33, currently residing in Mega Bay 2, represents the next evolution in spacecraft design. After passing its cryogenic proof test with flying colors, it's preparing for its own crucial engine test at Massey Outpost. The upgrades are nothing short of revolutionary: redesigned fins that could finally solve the atmospheric re-entry challenges that plagued earlier flights, enhanced heat shields that push the boundaries of material science, and larger tanks that extend the spacecraft's capabilities beyond anything we've seen before. But SpaceX isn't just building one ship at a time. In a display of industrial orchestration that would impress Henry Ford himself, the payload section of Starship 35 entered High Bay on December 7, marking the beginning of preparations for Flight 9. This parallel processing capability shows SpaceX's commitment to rapid iteration and improvement. The January 11, 2025 target date feels ambitious, but SpaceX has been known to surprise us. They've already demonstrated their ability to compress timelines in ways that seemed impossible just months ago. During Flight 6, they rewrote the rulebook by skipping traditional test sequences and completing the full stack just 3 days before launch, a feat that had veterans of the space industry doing double takes. However, this accelerated pace comes with its own set of challenges. The team faces 2 major hurdles: regulatory approval from the FAA, particularly regarding NASA's recent launch date request, and the technical complexities of implementing new recovery systems. The latter is especially crucial. Perfecting the booster tower catch mechanism could be the key to achieving true rocket reusability, a goal that's been the holy grail of spaceflight since its inception. The upgrades on this version of Starship aren't just incremental improvements. They represent fundamental advances in spacecraft design. Each modification addresses specific challenges observed during previous flights. The new heat shield design, for instance, incorporates lessons learned from earlier missions, where atmospheric re-entry proved particularly challenging. The enlarged tanks aren't just about carrying more fuel, they're about extending mission capabilities and opening new possibilities for deep space exploration. Behind the scenes, SpaceX engineers have been working on sophisticated computer models to predict and optimize the performance of these new systems. Sources close to the project suggest that the improved fin design alone required hundreds of hours of computational fluid dynamics simulations, resulting in a configuration that promises significantly better control during the critical re-entry phase. The testing sequence itself has evolved based on data from previous flights. Engineers have refined their procedures, focusing on the most critical parameters while streamlining less essential checks. This optimization doesn't mean cutting corners. Rather, it represents a more mature understanding of what really matters for mission success. Each engine on Booster 14 undergoes individual testing before being certified for the full static fire. Sensors monitor everything from thrust vectors to combustion stability, generating terabytes of data that inform both immediate go-no-go decisions and future design improvements. The level of instrumentation on these tests exceeds what was possible just a few years ago, providing unprecedented insight into rocket engine behavior. The implications of these advancements extend far beyond just this flight. Success here could accelerate SpaceX's ambitious plans for lunar missions and eventually Mars colonization. The improved heat shield technology, for instance, could be crucial for surviving the intense conditions of Mars' atmospheric entry. The enhanced tank design might be the key to storing sufficient fuel for long-duration spaceflights. The testing schedule remains intensive but methodical. Following the static fire tests, engineers will spend days analyzing the data, checking every system, and potentially making adjustments based on their findings. This attention to detail, combined with SpaceX's agile development approach, has already yielded impressive results. Each Starship flight has demonstrated significant improvements over its predecessor. What makes this particular moment in Starship's development so exciting is the convergence of multiple technological breakthroughs. The improved fins, enhanced heat shields, and refined recovery systems aren't just separate upgrades. They're part of a holistic approach to creating a fully reusable spacecraft capable of interplanetary travel. Each component has been designed not just to function individually, but to work in concert with all other systems. As we witness this pivotal moment in spaceflight history, it's clear that SpaceX isn't just building rockets. They're forging the path to humanity's multiplanetary future. From the fog-shrouded arrival of Booster 14 to the revolutionary upgrades of Starship V2, each step brings us closer to making space travel as routine as air travel. The success of Flight 7 could mark a turning point in our journey to the stars. With enhanced heat shields, redesigned fins, and improved recovery systems, SpaceX is solving the complex puzzle of reusable spaceflight piece by piece. This isn't just about launching rockets. It's about opening the door to Mars, establishing a permanent lunar presence, and unleashing humanity's potential among the stars. The preparations at Starbase tell a story of innovation, determination, and relentless progress. As January 2025 approaches, we'll be here to bring you every development, every test, and every milestone of this extraordinary journey. Want to stay at the forefront of space exploration? Join our growing community of space enthusiasts by subscribing to Elon Musk 24 Hours. Hit that like button if you're excited about Starship V2 and share your thoughts about Flight 7's potential impact in the comments below. Share this video with fellow space enthusiasts who need to know about these groundbreaking developments. Turn on notifications to catch our next update on SpaceX's journey to revolutionize space travel. Thanks for watching, and we'll see you in the next video as we continue to chronicle humanity's greatest adventure. Breaking records and pushing boundaries. That's what SpaceX delivered this week with Starship Flight 6, treating us to an absolutely spectacular daytime splashdown that lit up the skies. While we may have missed out on that super heavy recovery, This mission packs some incredible firsts. The first ever Raptor engine ignition in space, a pioneering payload, even if it was just a stuffed banana, and a groundbreaking new re-entry profile that put those massive control flaps to the ultimate test. But that's not all that rocked the space industry this week. We witnessed an unprecedented surge of activity, 5 Falcon 9 launches painting the skies, Rocket Lab advancing their IoT constellation ambitions, fresh progress on NASA's Artemis program, and Blue Origin's New Glenn standing proud and tall at the launch pad, ready for its historic hot fire test. From mission control to the vast expanse of space, this week has been nothing short of extraordinary in humanity's journey to the stars. This is Elon Musk 24 Hours. Let's dive right in. The morning sun painted the Texas sky in brilliant hues of orange and gold as Starship Flight 6 stood ready on the launch pad at Boca Chica. The massive rocket, gleaming in the early light, represented not just SpaceX's latest achievement, but humanity's boldest dreams of interplanetary travel. As the countdown reached zero, the ground trembled with the unleashed power of 33 Raptor engines, and history began writing its newest chapter. The launch itself was a symphony of controlled power. Flames erupted from the base of the rocket, turning the concrete pad into a tempest of fire and steam. As Starship cleared the tower, the gathered crowds gasped in collective awe. This was the first time they'd witnessed such raw power in broad daylight. The crystal-clear conditions offered unprecedented views of the massive vessel's ascent, each second revealing new details previously hidden in pre-dawn launches. Through the flight controller's calm voice, you could hear the subtle tension as the Starship approached max Q. The vehicle pushed through the sound barrier, generating brilliant shock waves that rippled through the humid Texas air. Each milestone came and went with precision. Vehicle is supersonic. Max Q achieved. Performance nominal, but the real test was yet to come. The hot staging sequence began like a carefully choreographed ballet of engineering. Ship 25's engines roared to life while still attached to Booster 13, a maneuver so complex that only a handful of rockets in history have attempted it. The separation, when it came, was pure poetry in motion. Against the deep blue sky, the two vehicles parted ways in a spectacular display of flame and precision, each embarking on their own crucial mission. As Booster 13 began its descent, anticipation built to a fever pitch. This was supposed to be only the second ever catch attempt using the massive mechanical arms of the launch tower. In mission control, engineers monitored countless data streams, preparing for a historic moment. Then suddenly, warning lights flashed. The launch tower's communication system had gone dark. In those crucial seconds, SpaceX faced a critical decision. The booster was performing perfectly,